it said particle starts. Okay, one thing you have got to do on the test, Sage asked how to study for it. One thing to prep yourself is you have got to read slow. Like force yourself to go twice as slow as you think you should go. Literally. Like slow way down. One word at a time. Particle starts. Keyword is starts. That means time equals 0. So when time is 0, and remember, in many problems, you're converting the story to data points on a graph. So time equals 0, particle starts from rest. Okay, that's another keyword. That means that at time equals 0, the velocity's value is 0. So as soon as they tell me the particle is starting from rest, it means at time 0, the value of the velocity is 0. So if I were making a plot of the velocity, I would have to say on my velocity plot, there's a point right here. Remember, when you look at a graph, you're not seeing the particle. You just see information. The plot tells you when time is 0, the velocity is 0. Any questions about that? Please.
When it says from rest at the point 2, 0, why is it at 0, 0 instead of point rest?
Perfect question, Maya. So they're combining a whole bunch of information in just a few words. So I haven't gotten to that one quite yet, but I will in a second. So far they've just told me there's some particle, again, I'm the particle, right? It's moving, but at time 0 it actually isn't moving. It's just stopped, and then it begins moving after that. So on the velocity plot, I have to have a point that indicates that. The position plot will be different. I'm not sure that's helping quite yet, but let's just be patient for a minute. I think it'll make more sense. Good for Maya. Luke.
So the multiple choice, are those supposed to be a velocity or a position graph?
So we have to keep reading. Point for Luke. So the particle starts from rest at the point 2, 0. Okay, right there is the classic AP clue that is designed to cause everyone to pick the wrong answer. Like that's how they catch literally half the country into choosing the wrong response. The particle starts at the point 2, 0. That has nothing to do with this graph. Answering Luke's question, there's 2 points. They want to know which of the following could be a graph of the distance s of the particle from the origin. You watch me again. I'm the particle. Right here I am at the origin, location 0. My position, we've been doing this for days, is -10. I am 10 from the origin. My position is -20. I am -20 from the origin. So when they say which of the following is a graph of the distance, that's the same thing as saying position. Like distance from the origin and position are the same thing. If that doesn't click, wave at me so we can talk about it more until it does click. A graph of distance from the origin is no different than a graph of position. They use the symbol S. I've been using the symbol X because they also use that symbol. So they'll go back and forth. Sometimes they'll say S of t, sometimes they'll say X of t. But in this case, answering Luke's question, there's 3. They're looking for the graph of the position. Okay? Question. Okay, here's why this is such a deadly clue, 2, 0. This is the graph of the position, but as I say over and over again, this is not the particle. You don't look here and see the particle, I'm the particle, okay? In this story, they're saying the particle is on a completely different grid. They're saying, well, this is your graph of position, but the particle's over here on this grid, okay? And on this grid, the particle simply moves back and forth like this. Particle does this. Just moves along this line on this grid. This is where the particle is. This is a graph. It gives you information about the particle, but it's not the particle. So 2 comma 0 over here is right here. 2 comma 0. So on this grid is where the particle is located at time equals 0. So this coordinate 2 comma 0 is referring to this grid over here, 2 comma 0, because it says the particle starts at that location, you know time is 0. So in those, I don't know, 10 words or whatever, they've conveyed a whole bunch of information. The velocity at time 0 is 0. So if you had a velocity graph, it would look like that. The grid that the particle moves on looks like this. And the particle is right there when time is 0. But this is not a graph of position, because a graph of position isn't the particle. It's just data about the particle. Anyone want me to talk more about that? Just wait. You have a question? Please.
So does the 0 and the 2 0 have anything to do with time equals 0, or is that just a
Outstanding question. So this 0 has nothing to do with time. It's just saying on this grid system, that's where the particle started. They could have said something like this, Lauren. They could have said, hey, the particle's on some grid, and it's going to start at, I don't know, 2 comma 3. So that would put the particle here. And then the particle moves back and forth like this. So that's all they're saying. 2 points for Lauren. Anybody else? Okay, so with this information and knowing that a position graph, see, remember, when you make a position graph, you're plotting data points. You're saying at different times, what is the position of the particle? That's how this graph gets created. This isn't the particle, it's data about the particle. So talk to each other, take a minute. Based on the information we have discussed so far, several of these are still possible valid answers. Talk to each other and raise your hand when you can tell me which of these, based on the information we have discussed, would be a possible valid answer so far. Go.
And it's also concepts
So when it becomes this is the acceleration.
Joe, I think I did 1 and 1, yeah.
So what was the?
That's what I heard.
But it's that's not because acceleration.
What's more likely, the delta is wordless or the passive?
You're so good. Because in our class, we'll just figure out how to use it. We talked about it.
Yeah, I'm hoping Tom breaks his column. I'm hoping that Tom breaks his column.
Hey, look out. fight against it. Jack asked a really good question. Look, he said, okay, in my little examples, I was trying to answer Laurel's question. There's another one. I said they could have described a particle that begins on some other grid at this point. And then in our class, we only study motion that's either back and forth or up and down, not a combination. So as this particle moves back and forth, the fact that it always has a y-coordinate of 3 on this grid is irrelevant. It always has that y-coordinate. So the graph you would create for position for a particle that's on a grid like this or a grid like this would be exactly the same. Because the position I'm worried about is this number. Because that's going to change as time goes on. The 3 wouldn't change. It would always have a 3, so I don't even plot that. Please.
How do you tell which one's going to change over time?
Gracie also saw that, but for Gracie there's 2. It says here, it moves along the x-axis. So they're saying, okay, you've got this grid where the particle actually is moving, and it moves like so. Does that answer your question, Chris? 2. Anybody else? Awesome. So raise your hand, please. Who is able to identify which of the there's more than one. Which of the following properly matches this whole idea that the particle is starting at 2, 0 on this other grid system? Yeah, come on. About half of you. Got another third kind of want to raise their hand, but they're a little uncertain. We're reluctant to be called upon. Let's go, Jared.
C and D.
So Jared went with C and D. Please raise your hand if you agree with Jared. Show me your hand. Sorry, you're up. 2 points. Let me point out the error here. Look up. This is the trap the AP test writers are setting for you. It goes back to the fundamental idea that this is not the particle. This is data about the particle. This point right here, this is points for the whole room. That has an x-axis coordinate of 2 and a y-coordinate of 0. But this is a graph of position versus time. So raise your hand if you can tell me, what does the 2 and what does the 0 represent in this graph? Come on, you have more know than you're raising your hand. What does the 2 and the 0 represent, Katie?
The 2 is time, and then the 0 is
It's position. Yeah, because it's a position versus time graph. So this would say at time 2 seconds, the particle is at location 0. Over here where the particle is actually moving, that would put the particle here at time equal 2. That doesn't match with the clue. The clue says at time equal 0, the particle is here. We need to make the position graph reflect that information. Like we've got to fill out this table so that at time 0, the position value is 2. That's why I repeatedly say this is not the position. This is data about the position. Questions? Okay, so how many knew that the correct answer was possibly either A, B, or E, because each of those has a point that is at 0, 2, and as Kate said, another point, time 0, my position is 2. Time 0, my position is 2. Time 0, my position is 2. That matches. How many knew it? 2 points. Okay. You didn't want me to talk more about it. Okay, going back to Sage's question, another point for her. How do you study for the AP test? This is the kind of thing you have to do. And look, it's really simple. You can either, it's going to sound kind of harsh, but it's very accurate. You can take my word that unless you focus on concepts, you will be utterly, like you'll fail. Like you have to focus on the ideas. You can't just say, oh yeah, 2-0, 2-0, I'm good, you know. Like, you gotta know what they mean. You have to do exactly what Kate was doing, another point. You have to say, wait a minute, what does this mean? Oh, this means at time 0, particle is located at position 0 over here. It's the meaning that they're testing you on in this class. Because that's what you're going to get tested on in college. College has no value if all you do is memorize a bunch of stuff. No one needs to do that anymore. It's like all right here. Like, you can find everything. You know, so memorization is becoming fast less important. It's a combination. It's like you have to memorize enough and then understand how it works. That's real value. So, questions here? Finishing the problem, it goes on to say, moves along the x-axis with a constant positive acceleration. I go right to Danica's chart. The acceleration is positive. Oh, so my position graph must be concave up. And then I'm done. Questions? This is a really good example of, if this makes sense to you, like, you can literally say, I'm not just copying the problem, like, I get it, I can see what the symbols mean, I can see where they come from, then you're on the right track for success. So please.
So would you have to use the chart, or can you just look where it says constant positive acceleration and know that it's going to be like curved like that?
You can properly reason it out that it needs to curve like that. I would worry that way too many people don't reason it out. They just make kind of a wild guess that constant positive acceleration is going to look like that. That would make me nervous. Like, that's not a reason, just kind of like, oh, I'm pretty sure it looks like that. They'll find a way to do you if you do that. So I think it's better to rely on the chart, personally. Good job, Sage. Luke?
I was just thinking, like, if it were like constant acceleration, then would it be like a straight line since it's accelerating at a constant rate? So it's kind of, it's more linear because the acceleration isn't changing.
So, point for Luke. There's the fish. That's a good chair. Score. Thank you. Oh, it's all good. Sorry, distraction. Look, Kate. What you're doing, Luke, is there's 2 points. You're making common errors as well. Everybody does it. When you say the graph would be sloped, it all depends on which graph. This is the position graph, absolutely. And the reason it makes sense is, okay, the acceleration is constant and positive. Acceleration is rate at which velocity changes. That means the velocity is changing at a constant rate. So the particle starts out not moving at all, and then its velocity goes up and up and up at a constant rate. So the velocity graph has the appearance you talked about. It's doing this. The velocity value as time goes on is becoming greater and greater.
Its position is getting faster and farther and farther.
The position, you have to play it with time. You have to say, as a little bit of time goes by, my position changes by a little bit.
But the more time goes by,
Right.
it's getting
Next section of time, my position changes by a greater amount. That's because my velocity was greater. Greater velocity means greater change in position. The acceleration graph actually looks like this. It's just constant and positive. So I still think what's messing with a lot of you is this. Look at me, come on, look. You look at the graph and you're trying to see the particle. Don't do that, it doesn't help. You look at the graph and you see data. Like right here, the acceleration is 5. 3 seconds later, the acceleration is still 5. 3 seconds later, the acceleration is still 5. That is a constant acceleration. It's always the same. So, please.
So, for constant positive acceleration on the velocity graph, if it was, so you would go to positive and then it says increasing, so it would just be that straight linear line.
So you're looking here where it says velocity is
Yeah.
increasing, the acceleration has to be positive.
So that it would just be a straight.
Positive doesn't mean the acceleration has to be linear. It just means the acceleration has to have positive y coordinates. In this problem, they told us the acceleration was constant. That's what made it linear.
So what if it didn't tell us that it was constant, if it just told us that it was a positive acceleration?
That still would have led me to choose this one.
Okay.
Because if the acceleration is always constant, combination of positive and constant, if the acceleration is always positive, the graph of position has to be concave up. So they would not have had to set the word constant. So, maybe else. Should we forget it? Okay, go to the front of the packet now.